What do you know? This is 3-8, the last lesson in Chapter 3. And this one is kind of cool. It's about solving equations by clearing fractions. For those of you that don't like working with fractions, you'll like this because it gives you a chance to get them out of the equation very early on so you don't have to deal with them. So here's the idea, is to find a good multiplier to clear the fractions. Now you should read through the lesson, of course. This first part takes you through an equation, this one right down here, that you're going to put into a CAS and look at what happens when you multiply through by 2 and then by 3 and then by 6. And you'll find that when you finally get to 6, it works and all the fractions are gone, which is what you're after. You don't want to have any left behind. And it gives you a good opportunity to then solve it in the ways we've done before. We've learned about this. We'll go through the activity after I wrap up talking about this lesson. You do want to make sure you've got the vocabulary down for all of this, and then we'll continue on with example 1. I'll provide you a couple of examples like this. You can always check your answer with a CAS, but it's good to be able to do it by hand because you're going to have to. So don't just totally depend on that. Use it as a tool to try things out and to check and see if your work is right. This particular problem in example 1 is another context problem, and it gives you some fractional information that then needs to be broken down into an equation. And you just have to figure out, well, what are they talking about? What's the variable going to be? And how much is the total? In other words, what is the whole thing going to equal? And right here, what was the league total income for 2004? And from that you can find out, because you know the combined income. The combined income is these fractional amounts times the total income. So we'll see. Okay, clearing fractions and inequalities is just the same as if we were doing it in an equality, except for what? Anybody remember? Okay, I'll remind you. If you happen to multiply through by a negative fraction, then you have to flip the inequality. Now there's really no reason to do that at the fraction phase where you're trying to clear the inequality, but who knows, you might, so pay attention to it. The next section is about clearing decimals. Pretty easy. Example 3 takes you through it. In other words, at 5.85, I need to multiply that by 100 to move the decimal place 2 decimal places to the right. So 100 times 5.85 would be 585. So if I multiply everything by 100, then I no longer have a fraction with decimal terms. Covering the ideas and applying the math is your assignment. Bring your questions in, talk to your friends about it, make sure you get all the reading done, and get ready for the mastery quiz. Okay, we'll go back to our activity and proceed with that. Okay, we're on 3-8, going through the CAS work. Hopefully you were able to do the work on page 167. I'm going to go ahead and go through the activity on page 168. Entering this data is the same as what you did on 167, so perhaps if you got stuck, this will help you out. So we have a open parentheses, and then t divided by 3. T divided by 3 plus t divided by 2 minus 350. That whole thing equals 270. We're going to close the parentheses, and now we're going to multiply this whole thing by, well, what did it say first? It was by 2, right? Okay, we did a 2, 3, and 6, and now it's saying experiment to find 3 more multipliers that clear the fractions and record your results in the table. So I got 2, 3, 6. 6 worked. 3 didn't and 2 did not. So I think I'm going to try 12. So, because 2 times 6 is 12. That's the only reason. Let's see. So I'll put in times 12 and enter, and I get a problem without fractions. So 12 worked. And also 12 is divisible by 3 and 2. So I think that's the key here, is finding something that would work for both. And if that's true, then that would mean something like 15 won't work, because, well, 2 won't go into 15. So I need something that can be divided by 2 and 3. And if it can be divided by 2 and 3, that must mean it's divisible by 6. Right? Because that's how that works. If it's divisible by 2 and 3, then it's divisible by 6. So let's see, 14, nope, only 2, not 3. 16, only 2, not 3. 18, 2, 3, and 6. Try it, see what you think. So let's try something else. Again, we start with open parentheses. We put in our t divided by 3 plus t divided by 2 minus 350. Close. No, we don't close parentheses. We make it equal to 270. And we close the parentheses. And now we're going to multiply it by something. So try something that you think would be good. I would say I'm going to try 36. Maybe. Yeah, why not? Let's go with 36 and see what happens. Times 36. And I put in enter. And I get that indeed it does clear it, getting bigger and bigger numbers. It's clear, I think, as you go through this. You'll want to find some others. But what you're going to find is that if this is true, then the easiest thing to do would have been 6, because that gave you the smallest overall values in the equation. Everything else gave you somewhat larger numbers to deal with. Now, that's not the end of the world if you have big numbers, but if you can get to the smallest factor that can be multiplied through to clear the fractions, then that's better for you. It's going to make it a little bit easier to work on. So go ahead and try it, see what you can get on it with that last one, and then we're going to carry on with an example. When we get to the next example, go through it pencil and paper, do it by hand first, and then if you want, check your work with the CIS. Use that as a way to verify that you got the right result. Okay, we've got some additional examples for 3-8. Let's take a look at some of them and see what we can do here. So here's our first one, just a basic clear the fractions problem. Negative 2/5 times m plus 1/6 equals 3/2. Now, what we want to find is something that that is divisible by 5, divisible by 6, and divisible by 2. And so that means it's going to be the first number that we come to that's divisible by both 5 and 6. Because if it's divisible by 6, it's even. It'll be divisible by 2. For it to be divisible by 5, it has to be end in 0 or 5. So we're at 5, 10, 15, 20, 25, 30. We've got a number at 30. So we multiply through by 30. And you can see as I've done this, I've multiplied every term by 30. You can't just do one and then skip to the other side. Everything throughout the equation will be multiplied by 30. So if 5 goes into 30 6 times, negative 2 times 6 is a negative 12m, plus 6 goes into 30 5 times. 5 times 1 is 5. And 2 goes into 30 15 times, and 3 times 15 is 45. So now we're in the form that we've seen before, and we know how to solve this. So we go to our procedures where we undo the addition. We'll subtract 5 from both sides of the equation, and in doing that, 5 minus 5 is 0, and 45 minus 5 is 40. We will now have to deal with this fraction. So a negative 12m times 1 over 12, that's a negative, equals 40 times 1 over 12, and we get negative. Don't forget those. Okay, and then m is going to be equal to 40 times the negative 1/12. And let's see if we can figure that out. So that's a 40 over 12. That's a negative. And so let's see. 2 goes into both of those, right? So that would be 20 and 6. And those can both be divided by 2 also, so that would be a negative 10 over 3, a negative 10/3. Nice improper fraction. All right, let's look at another example. This one will be a little bit different because we'll have to figure out what the equation looks like. So this says, write an equation to describe the situation and solve it by clearing the fractions. The Smith family budget allows them to spend 1/12 of the family income on recreation and give 1/10 of the family's income to charities. The Smiths spent $13,200 in 2005 on recreation and charities together. What was the family's total income for 2005? Well, the variable we're after is total income, and we'll use T for that just because it's there. You know, we could use I, you could use whatever you want. Just good to have something that helps you keep and make sense of it. And what we know is that they spent $13,200 on both recreation and charities. So that total amount they spent was that amount, and that would give them, let's see, 1/12 of their total income plus 1/10 of their total income is equal to 13,200, right? So that's what they spent together on that, and together one of them was 1/12, one was 1/10, and there we go. So now what we want to do is to clear the fractions out of this equation, and so we want to find something that would allow both of these to go into 10, both of them to be divisible by each one of these by 10 and by 12. If it's going to be divisible by 10 evenly, it's got to end in 0. And so we kind of go through, we got 12, 24, 36, 48, 60. 60 ends in 0. So it looks like what we're going to want to multiply through here by is by 60. So we've got 60 times 1/12 t plus 1/10 t equals 13,200 times 60. Now in this case I went ahead and I wrote this in parentheses rather than putting each one in there, we know that we're going to use the distributive property here, and 60 will be multiplied by both of these terms in order to get our final result. But in doing this, I can go ahead and look at what am I going to get when I divide these things, and I think it's going to be relatively straightforward. I don't know. So let's see, 60 divided by 12 is 5t plus, well, 10 goes into 60 6 times, so that's 6t. And that's going to be equal to, I don't know what this is. I'm going to grab a calculator. Ooh, that's a big number. 792,000. Well, that's a lot, but that's also 5 times their total income plus 6 times their total income equals that amount. And 5 plus 6, well, that's pretty easy to deal with. That would be 11t equals 792,000. We multiply by 1 over 11. So 792,000 divided by 11 equals $72,000. So with partial information, we know what they spent on recreation, we know what they spent on charities, and we knew what proportion or what fraction that was of their total income. And with that information, we could then determine total income with just that bit of information. So that's another example about how you can take the given information, create an equation out of it, clear the fractions, simplify, and by combining terms, solve for the variable, and you have your answer. Here's another one when this involves an inequality. What we're doing here, again, it's clearing fractions. As soon as we've cleared fractions, we're dealing with it following the rules we learned for solving for inequalities. So x over 7 minus 2 is greater than 1/2. We need something that can be divisible by 2 and 7. Well, 7 is not, 14 is, so there we go. We're going to multiply through by 14. So let's see. 14 times x over 7 minus 14 times 2 is greater than 1/2 times 14. So it looks like we've got it. We had to multiply everything by 14. So 7 goes into 14 2 times, so that's just 2 times x, minus 2 times 14 would be minus 28, which is greater than 1/2 times 14. 2 goes into 14 7 times, is greater than 7. Now we have something we can solve. We're going to add 28 to both sides of the inequality. 2x is greater than, what are we going to get here? 28 and 7 is 35. And so divide both by 2. 2 goes into 2 one time, leaving me with x. It's a positive, so I leave the inequality going the same way. And 2 goes into 35 simply as an improper fraction, 35 halves. We can stop right there. You could, if you wish, make that into an improper fraction. Make that into a mixed number, but I find working with improper fractions is a lot easier. If we need it as an improper fraction, we can write it as an improper fraction. But we'll stop right there. X is greater than 35 halves. Okay, one more and then wrap it up and let you get on with it. And this one is solving a decimal equation. Remember, all we're really looking to do is to move the decimal point. And so for this one, it's only one place. From 7.2, we'd like to move that over one decimal place. But for 1 and 12/100ths, we have to move it 2 decimal places. And so that's what's going to determine our multiplier, which to move it 2 decimal places means we need 100. So 100 times 1.12 n minus 100 times 4 equals 100 times 7.2. This means we move the decimal point 2 places. That's 112 n minus 400 is equal to that was 2 places, 720. So now we go ahead and we do our addition, then followed by division. We're going to clear this out by adding 400. Add 400 plus 400. That becomes 0, so I'm left here with 112n, and that's going to equal 1,120. And now we're going to multiply by the reciprocal of 112, so 1 over 112 times 112n equals 1120 times 1 over 112, and 112 goes into 1,120 10 times, so n is equal to 10. We are done. So that's some examples on how to clear fractions. You can choose to do it or not. If you're, when you're asked to do it, please do so, of course. But when you're working through some problems on your own, you might see an opportunity to clear fractions, but view it as perhaps not necessary. You'd be able to manage it with fractions just fine. So carry on with this. Get to the mastery quiz, then get yourself prepared for the examination for Chapter 3. Remember about the self-test. I've got a note here for the self-test that problem number 9, that the solution in the solution sheet is incorrect. Have to make sure we get that corrected, so somebody, when you get there, remind me when you hear this and check and see if I've done that. Thanks a lot. See you in class.